So we have solved this question using M1 as origin, M2 as origin as well. Now let us see the third option and the final option, which is considering center of mass to be the origin and calculating the positions of M1 and M2 relative to the center of mass. And since center of mass is the origin, the coordinates of center of mass, which is x bar comma y bar, would be equal to 0 comma 0, right? And if you were to understand the diagram with y-axis, x-axis, origin, and what is present at the origin, the center of mass center of mass C is present at the origin, having the coordinates x bar comma y bar, right? And what is A? A is the location of M1, which has the coordinate x1 comma y1. What is B? B is the location of mass M2, which has the coordinate x2 comma y2, right? Now what is the value of x1? The value of x1 is the distance between A and center of mass, which we assume to be r1. Okay, and the distance between center of mass and B, we assume that to be r2, where the complete distance between them is r. Hope that makes sense. Let's see that one more time. Distance between A and B, or in other words, distance between masses M1 and M2 is r. Distance between M1 and the center of mass A and C is r1. Distance between center of mass C and M2, that is C and B, is r2. So x1 would be minus r1. Why? Because m1 is placed along the negative x-axis and m2 is plus x, which is m2 is plus r2 because m2 is placed along positive x-axis. So if we calculate x bar from this expression, what do we get? X bar is equal to 0. Why? Because it is at origin. So 0 is equal to m1 x1 plus m2 x2 by m1 plus m2. So we have here m1 x1. What is x1? It is minus r1. My bad, I have written this. This should be m1 x1 plus m2 x2, which actually is equal to m1 into minus r1 plus m2 into what is x2? X2 is plus r2. So when this is equal to 0, m1 plus m2, when we transpose this, that also becomes 0. So what we have is m1 x1 is equal to m2 x2, or in other words, what we have is m1 into r1 is equal to m2 into r2. All right. Now this is not what the question is all about. The question is asking us to find out the distance moved by B when A is moved by a distance of 2 centimeters. So when mass M1 is moved by a distance of 2 centimeters, the position of mass M1 changes from A to A dash. And we have to find the position of the change in position of B, say from B to B dash. Okay. So now we have two different set of positions. One which is A dash, the other which is B dash. A dash is the new position of mass M1. B dash is the new position of mass M2. Coordinates being x1 dash, y1 dash and x2 dash, y2 dash respectively. Now what would be x1 dash? Okay, I think it is better to see an example here. So let us say this is the origin. Okay, this is minus x. We're talking about r1, and if this object present m1 present at minus x, if it moves 2 centimeter towards the center of mass, what is the new position? It will be minus 6 plus 2, which is equal to minus 4, right? So this new coordinate is basically minus 6 plus 2. And if we don't, if this location is not specified, that becomes minus r plus 2 or minus r1 plus 2, right? So similarly, we have here the earlier position was minus r1. Since it has moved 2 units towards the center of mass, that becomes minus r1 plus 2. Correspondingly, since B is moving towards the center of mass along the positive x-axis, the earlier position of B was R2, the new position would be R2 minus, not x1, it is some random value x. Okay, so you may have a doubt here as well. Let us try to understand that part. So say this is the origin, okay, and we have the position of the original position of mass m2 at B. Now m2 has shifted some position along the x-axis. We don't know what value is that, some along position along the x-axis, which gives us the new value as b dash. Now say if this b was equal to 6, if b was equal to 6, and if x was equal to 2, what is b dash equal to? B dash will be equal to 6 minus 2, which is equal to 4. Simple. Similarly, if the position of B is equal to R2, what will be B dash? B dash will be equal to R2 minus X. Alright? Now pause the solution here. Watch this one more time if you can. And write down a couple of examples on your own. Things will become really clear because we need these calculations based on origin, especially the ones based on center of mass origin, many a times in the coming set of questions. Okay. So we derived two values of the coordinates, which is x1 dash as minus r1 plus 2 and x2 dash as plus r2 minus x1, not x1, this is again x. Okay, keeping these coordinates in mind, what is x bar is equal to 0? Why? Because it is still at the origin. It's given to us as my m1 x1 plus m2 x2 by m1 plus m2. And why is it still at the origin? Because it is given in the question that the center of mass is at the original position. And what is the original position? The original position is C. What is C? Origin 0, 0. So C dash, which is the new position, C, which is the original position, both of them are equal to 0, 0. Therefore, x bar, y bar, both cases are equal to 0. So I can equate x bar is equal to m1 x1 plus m2 x2 by m1 plus m2. x1 here is, from the graph, it is minus r1 plus 2. x2 here is r2 minus x. Now when we open the bracket, m1 into minus r1 becomes minus r1 m1 plus m1 into 2 becomes 2m1, m2 into r2 becomes r2 m2 minus x m2. So what I'll do is I'll just transpose the negative terms towards the LHS. So we have r1 m1 plus x m2 is equal to 2m1 plus r2 m2. But from the previous discussion on x bar, which is the original position, we have found out that m1 x1 is equal to m2 x2. What is x1? R1. So m1 r1 should be equal to m2 r2. One more time, from the previous discussion, we have m1 x1 is equal to m2 x2. Therefore m1 r1 should be equal to m2 r2, which means this r2 m2 can be replaced by m1 r1, and therefore these two terms will cancel. So what we get is 2m1 is equal to x m2. Therefore x is equal to 2m1 by m2. Value of m1 is equal to 3, m2 is 2, so 2 by 2 is 1, and therefore the value of x is equal to 3 units. Alright, so that's the way to solve this question using center of mass as the origin. Okay, now we have another question based on center of mass. This time it's on the calculation of center of mass of a triangular body. Oh, well, not exactly a triangular body, but a body which resembles a triangle. And we'll try to see 2 to 3 different methods to arrive at the solution for this question. In the meanwhile, you can, invest more time in understanding the way these coordinates are calculated. Okay. All right. So let's move on to the next question now.